Okay. This is the second video, tutorial video. So this video will focus on doing the load map before the conceptual plan, because for the load map, it will be the reference of the conceptual plan. Okay. So let's go back to the structure folder. Let's open the, so we forgot to change the name of this one. Okay. So let's go to the last video is about CDRC, so we need to rename it after we finalize it. Okay. Now we go to we open again the conceptual plans. Okay. Okay, so it's already open here. We will generate a PDF copy of the plans. It's not platted, so maybe we can just create. Okay. So first we need to compare, but I think it's just the same in terms of loading. So we can go to the phase 2. This is the final form. Just need to create and then downloads. Okay. Save the desktop. Let's name it as, where is this one? Second floor. Second floor. Okay. So this is the second floor layout. Then let's create another copy for this one. So it's just happened that for this project, we have this some sort of information. It's like very raw information. But for some other projects, they provide already something like this. It's already organized. So for now, we just work with this one. We need to put it as ground floor layout. Okay. As I mentioned, we don't have roof framing, so we don't have roof loading that we can use for this one. We don't have the roof layout, but maybe we can assume later. Okay. So for the roof layout, I will close the CAD files. Put this to here. We'll just copy the second floor, and then maybe at least we have an idea of the coverage of the roof. So we just name this one as roof layout. Okay, so let's put this in our folder. So make sure to put it in the folders. Elements, downloads, PSQ folder, SD1, architectural. Okay, so that one is we have. Okay, let's start the loading. For the loading, we will copy the layout. Let's move the layout. Sorry, we need to copy the layout to the load map. Okay, something like this. This is a template that we are using for the load mapping. Okay, so again, set the date 200709. Okay, so this is 09. Okay, so I'll open the Excel file. This Excel file already consists of the procedure, okay, and the loading as per NSCP 2015-2015, okay. So this was already the latest one, and we will follow the procedure, okay. So first, we need to review the architectural layout and section. Okay, why do we need to open that? To identify the step 2, which are the finishes, and then the wall designations. Then step 3, establish live load per occupancy. So let's do this first, the tree. Let's establish first the tree. Okay, on the SDL tab, let's go to the SDL tab. So this is where we will establish the occupancy. Let's move to our plans. Let's open the file. Okay, so as you can see, we have this part of occupancy. We have the retail. We have a small storage area. Okay, some sort of storage area. And mostly our this escalator, we have opening. In general, the occupancy is retail. So we can assume that it is retail plus storage and this at this portion. So we have two main loadings. Okay, and then this one also. The room, utilities, some sort and other things. Okay, the second floor, there's still the CR and then utilities here. But to make it simple, you can define it as room, retail, and storage. Those are the major occupancies for this one. Since the bathroom or the toilet is always referred to the usual use of the structure. And it has a smaller loading. Okay, so we have a retail. Just put retail there. Then we have a room. So we have this one. We have the storage. We have the room, utilities, utility room. So let's put it there. Utility room. Okay, what else do we see? CR will be just the same. Hallway, we can define hallway also. But since hallway load is smaller than the retail, let's check. Okay, it's just defined. So we can compare later. Hallway, and what else do we have? Ground floor. Okay, that's all. Anyway, this outside is part of the site development, so it won't affect our building. So no need to consider that kind of occupancy. Okay, so that's it. Then we have a roof. We have a roof. Okay, so first let's define the live load. The live load, we need to identify what's the live load for the retail. So just go to the live load tab. Look for the retail. Retail. This residential. Stores, okay? Retail, so we have 4.8. So just put there 4.8 kPa for the retail. Storage, let's go back, just do the same. Light or heavy. So since this is a retail, most likely they will be selling goods that can be dress or any. So just to make what do you call more conservative, let's put 12. Okay, let's consider this one, the heavy. Okay, then utility room or gen set rooms. Let's look around. Utility room. Gen set rooms. So do we have a specific loading for that one? So we don't have. Okay, we don't have specific for that one. So what we can do is to consider the storage. Let's consider it to be 12. That's for conservatism since it's just very small. The area is quite small. Then hallway. Let's check the hallway. Let's go back here. Hallways, stores, bridges and hallways, walkways, pedestrian bridges, 4.8. Maybe it can be an option. Sidewalks and driveways. We don't have sidewalk and driveway here. You consider it like that. Okay, let's move up. Manufacturing. Corridors, you can consider it corridors, although this is not a manufacturing. And exit facilities. Okay, so it can be considered also. Catwalk maintenance, bowling alley, theaters, armories. Okay, so in general, for the access floor system, we can use this one. So it's we don't have that much information. We can just use this pedestrian bridge and walkways. Anyway, it's just the same. No? It's just the same of the utility room, of the retail, sorry. So it is bounded by retail, so we can use that one. Roof, for roof live load, let's go back to the live load. Go to the roof, live load here. Okay, so we can use this one, hereditary. So definitely it is over 60 square meters for sure. Then its slope, so it doesn't matter. No? If it is over 60, then you can just use 0.6. Okay, you can just use 0.6 kPa. So let's just use 0.6 kPa. Okay, now what are the loadings that we expect? What are the superimposed loads that we expect that these occupancies will have, or will be their partners? Okay, so most of the time we don't have yet the, what do you call this, the finishes. Okay, the schedule of finishes. So most of the time we don't have that. So for now we will use the, we can assume that it will be tiled. So maybe it has a 50 mm tapping. So maybe definitely it has utilities. So utilities is 0.2. You can check it here. Utilities there. Mechanical allowance, so we assume it to be 0.2. Floor fill, so maybe it has a 50 mm tapping. So let's look for a tapping. Most likely it will be it can be stone concrete. So we will just multiply per mm. So 0.023 times 50, maybe 1.15. 1.15. So maybe it has a floor fill of 50 mm. Frame partition. So let's just use the standard 0.5 for the frame partitions. Okay. Although there's a lower value here for movable partitions and things like this, movable partition still, okay? But I think 0.5 is okay, just for conservative assumption. Coverings, you don't have that. Floor and floor finishes. So we can go there. Floor and floor finishes. This is the table of floor and floor finishes. Okay. Usually we use ceramic tiles. So ceramic tiles and 25 mm mortar bed. Okay, so that you can assume that one. Okay, so that's why it's 1.1. Then permanent wall. But for this case, I think we will not have permanent walls. permanent wall pertains to the concrete masonry. So I think we don't have permanent walls here. Most of them are movable partitions or movable, what do you call this? Movable units, retail units. Okay, so I assume this to be 0. And also for the permanent walls, we can directly input into the girder loads. Okay, so this will just be for the floor loads. Okay, then anticipated area. So for the anticipated area, we can use this one. Okay, let's refer to this one. We expect it to be this much for the live load reduction. So it can be a 12 by 12 B for the retail. And then for the EE and utilities will be smaller, 5.1 by 6.15. Okay, so let's put it there. For the retail, we have 12 by 12. We have this for the storage, we have 12 by 12. Utility room, we have 5.1 by 6.1. Hallway, so we can put it 12 by 12 because it's just the same as the retail. And then the roof. The roof is more than 60 meters, so we can assume it also by 12 by 12. Just for reduction purposes. Then we need to copy this one. For the storage, we can assume that it has a floor finish. Floor fill. For utility room, same. But it might not be in tiles. So we can make the floor finish 0 and then increase this floor fill. You can just double the floor fill. Or just put it like that. It can be like that. Hallway, definitely it will have tiles. So we just need to copy. Hallway. And then roof. Okay, for the roof, we don't have frame partitions, suspended frame partitions. Definitely we don't have floor finishes. It's already there. What we can do is to assume that there will be a solar panel. The solar panel is around, the equivalent mass is around 0.2 to 0.3. So let's just assume 0.5 for the panels, solar panels. Okay, so this will be our load combo. So we will have 1, 2, 3, 4, 5. So we will have 5 loadings, 5 type of loadings. Okay, per area. So we can now, this is already finished. Just save it. You can go to the earthquake parameters. So that's for the gravity, dead load, live load. Earthquake parameters. Okay, so let's set this one. So occupancy of structure is type 4, ordinary. You can say that this is just a regular ordinary structures, not special. Okay. Standard. Call it standard. Then concrete building width. So let's check. So this building width should be the lesser of the widths. Okay, so we have 66 and 6 meters. Okay, so we should not consider the 6. Only 1, 2, 3, 4. This is 48. And then for this one, 66. So 48. We can consider 48. Building width, 48, 1, 2, 3. Building height. Let's look at the section. So building height should be from the ground level. 3.7 plus 6.2. So that's 9.9. Okay, 1,900. Sidewalk level, meaning the ground floor is elevated from the sidewalk. So maybe we should add it also, the 900. Okay, plus 900. Weight of structure, we assume it point or just 1 kilonewton to make it in a unit of 1. And then the mass of the structure. Seismic importance factor 1 because it's from here, category 4. Then soil type, this is the tricky one since we don't have the geotechnical report. So we will refer to the nearest project, which is the Mandani project. Okay. So let's check the Mandani project. What does it has? Okay, so let's open. Okay, it takes a long time. So we can assume it to be D, but basically it should be coming from the geotechnical report. Apparently we don't have the copy yet. Maybe it's faster. I will just download. Okay, so just skip that one. Seismic source type. So this will be also coming from the geotechnical report as well as the nearest distance to the source. Okay. But for the nearest distance from the source, we can also get it from the fault finder. If you are familiar, so we can open the fault finder here. Fault finder. So you can get it here. I'm not sure it still works. Under fault system. So you just need to double click the location. So let's look for Cebu, 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 Cebu. There's Cebu. Then there's Mandaue. Let's look for Carbon. Talisay. I think it should be somewhere here. Should be somewhere here. Around here. Colon. Cebu City. So maybe somewhere here. Just for assumption purposes. But it will be better if you have the precise. No, it's not working. It's not working. Right. Okay. So we have a direct link for the fault finder. Here. We need to go to the direct link. Yes, since the most dominant will be it's not the valley fault, it's very far. Let's check for the nearest. It's near Cebu City, so it will be somewhere here. There, so it's around 3.8 kilometers. Okay, so just put 3.8 here. Zone 0.4 since we are in Philippines. Okay. Oh, I just accidentally press these ETABs. So let's go to the downloaded geotech report. So let's check. Here's the boreholes. These are the bore logs. Okay. Okay, so this is not what we need. Okay. So we need to download again the other file, the Brian Tan report. Okay, it's easily downloadable. So let's check. This is for Mandani. I would like to emphasize this is for Mandani project. So we just need to check. Okay, this is the seismic parameters. So we can use SD. This is the S. So SD. And then seismic source type. Okay, so this will be the distance. So this is the closest. So maybe we can consider this one. We can try type A 120 or C7. C 3.8, something like that. Okay, so let's try. So type A or 3.8, letter C 3.8. The output will be this one. So let's paste here. Okay, if it is A, and then the value is, let's say 100, value will be something like it. So it doesn't matter. Okay, so it doesn't matter because the source, although the source type is higher, it's very far. So let's stick to the closer one. So let's use C and then 3.8. Then for this one, we need to define what kind of structure. So considering the initial frame, go back here, we can use columns and girders. So basically, it will be a moment frame. Okay. Then let's go back here. So let's look. There's a moment frame here. Steel reinforced concrete moment frame 0.0731. So 0.0731. Okay. And then it will automatically compute. Then what kind of R? So since we'll be using moment frame, so a special moment resisting frame. Okay. So this will be the parameters for the dynamic case of dynamic analysis. Okay, so that's the parameter for the ito na yung sa, let's go to the wind load. So for the wind load, we might opt to consider the wind load. Why? Generally, we need that, but it will take a long time for us to analyze. So this is the premise why we can just ignore it for the building frame because it's open. Okay, the structure is open, so there's very minimal wind that we will be experiencing for the framing of the structure. But for the roofing, we really need to consider the wind. Okay, so that's it. Okay, so you can proceed next. Once you already establish, okay, floor load, beam loads, we don't have much perimeter wall. We have much perimeter wall for the beams. We can apply it directly. Beam loads. So that one you can just apply later. And this will be the beam loads for everybody's understanding. Okay. So for the beam load, these walls, these partitions, although this quite light, if this will be steel, then it might be already considered in the floor load using the movable because it's very light. But if you will be using concrete barriers there, then it will be very, very heavy. Okay. So these loadings and this drop panel. So we should consider this one, but this is quite not that much load. It's not that much heavy. Okay, so we need to examine the section for that one, for the beam loads. But anyway, most of majority of the structure is open, so we can consider it to be open. Then let's start the mapping. This is the final stage. Once we already define all the loadings, then we can start to map these loadings. So we need to prepare 1, 2, 3, 4, 5. So we need to prepare 5 colors for the loadings. Okay, so let's open the PDF plans. The one inside here. So let's go for the ground floor. So first, as mentioned, we need to establish the loadings, the colors. Now, what are the loadings here? Also, if you can see, the loading of the hallway in the retail is just one. So we can just put one color for them by both live load and dead load. So it's just the same. Okay? So it won't be that much. For now, I will not let you use the reduced live load. So just use the regular live loads for this loading scheme. Okay, so let's just put the orders here. So let's introduce this one. Okay, so let's use cyan. Okay, so put cyan there. Make sure it's multiply. Okay, let's use cyan for the retail. Retail and hallway. So make the font smaller to fit in. Then put the loadings. 4.8 live load, 4.95. 4.95 SDL, 4.8 AML. And press something like this. Just put it there. Okay. So we can use cyan. Then it will be the second color. This color first. That will be the cyan region. So I suggest you to use the area so that you already have the, in case you need the information, you already have the measurement. Okay? But to do that, first we need to do the scaling. Okay, so we need to check. So it's not scaled. Okay, so let's do the scaling. Set scale. Calibrate measurement from here to here. Make sure it's okay, it's aligned. To pick another point. So it will get okay, so let's put there 6 mm. 6,000 mm. Okay, see. Okay, now we can double check the distance if it's already fitting. So it's 6. Okay, so at least minimal error. Okay. Okay, so try again on the other, just to make sure on the other side. Should be 10. Okay, should be 10. Okay, so let's color now. Let's highlight the retail area. Just put it there. No, storage not part of the retail area, so you can put it here. And here, you can assume it in the toilet. Make it simple. There, and then let's put it here. And just color it. Simply coloring it. It's very simple. Just color everything, almost everything. Complete. And that's it. That's the retail loading. Then we can add another one. Copy this one and then paste another. Drop down. Change the color. Maybe we can use yellow. So what's the other loading? We already have this one and this one. Storage. So we can turn to this storage. Storage. So we can adjust this one to make it consistent. Okay. Loading of storage 2.95. 12. So we need to go 2.0 here. Okay, storage is yellow. So let's highlight it with yellow. Moment area using yellow colors. Make sure it's multiply. Okay, this is it. This portion. Let's color it. Complete. Okay. Then the storage. Oh, sorry. Wrong. It should be in the storage. Okay, something like that. And then the last part will be, the last type will be, just need to be consistent and then using our colors now. So that it's not confusing. It will be the equipment, utilities, utility room. Okay. What will be the loading utility room? 12, 1.85. So 1.85. Let's pick a color. Let's use maybe light green. This lighter green. Lightest green. Okay, let's go there. Area tab. Use the lightest green. This part is the more of just the drafting. So it won't take very long. Depends on the number of floors actually. So basically that's it. That's the loading. Right? You just need to put the name also of the floor. So this is the ground floor. So let's put it here. Sorry. Let's copy this. Ground floor. So you just need to do the same for the other floors. And that's the load map. That's how to do the load mapping. Okay, so I think that's enough to be the guide, and then you can do for the next, you can do the same for the next floors. Okay, so thank you. That's for the load mapping lecture, and hope everyone is managed to capture it. The next will be the concept plan. So we need this load map before we proceed to the concept plan. Okay, thank you. Bye-bye.